Chapter 21 is carboxylic acid derivatives. Look here, it is a carboxylic acid. In this part of it, the box is called a acyl group. The carboxylic acid derivatives, we derive them from carboxylic acid. If we replace the OH in a carboxylic acid with a halogen, it is an acid halide. If we replace the OH with NH2 group, it is an amide. Instead of replacing the OH, if we replace the hydrogen and the OH of the carboxylic acid, this one, with another alkyl or aryl group, it is an ester. If we replace that hydrogen with another acyl group, it is an acid anhydride. Let us go ahead and examine each one of them. Acid halide contains only one acyl group. Acyl group, I said already, this group. Amide contains one acyl group. Ester contains one acyl group. Acid anhydride contains two. Keep that in mind. The general formula is this one. If you use the general formula, it is easy for you to remember the reactions and mechanisms. This represents all the four derivatives. They are all different at this Y group. In acid halide, the Y group is a halogen. In amides, the Y group is an NH2. In ester, the Y group is OR group. In anhydride, it is another AC group. The acyl group, I call it as an acyl group. We can actually represent it by AC. So OAC group. How to name the carboxylic acid derivatives? We are going to use the method you practiced it when you are a small child. You have friends in the street. You're a friend, Mike. You call his father as Mike's dad, Mike's mom. But look at your grandmother. She will call some kids. She may not remember the name of the kids, but she knows her friend. Oh, this is Susan's daughter. This is Jackie's son. So the same method we are going to use it. For the carboxylic acid derivatives, the carboxylic acid is the mother. We are going to find the name of the mother, and from that, we are going to modify it, just like Susan's daughter. Look at it here. This part is not in the notes. This we had it in chapter 20. I just collect them here. Some carboxylic acid, still we use the common name. They are all end with ICN acid. We need not know the common names of all carboxylic acid. At least know the first two. This one is formic acid. This is acetic acid. You see the ending is IC acid. But for most of the carboxylic acid, we use the IUPAC name. Those names ends with OIC and acid. Look at the first one. This contains 4 carbons, so it is butanoic acid. ends with OIC. This one has 6 carbons. So this is hexanoic acid, ends with OIC acid. We also saw in chapter 20, there are some carboxylic acid. They contain COOH group on the aliphatic ring, not aromatic ring. This is an aromatic ring. So the 5 and 6 are the good examples. We call the 5, just we named the ring, add the word carboxylic acid. They end with this way, XYLIC acid. This is cyclopentane carboxylic acid. But this one you cannot use it, even though it has a COOH on the ring. The ring is an aromatic ring. The whole thing has the name benzoic acid. This is not in the notes. This is collection from chapter 20. Just to show there are 3 different types of names. Some end with IC and acid, some OIC acid, some carboxylic acid. Keep that in mind. We are going to name first acid halides. I have 2 examples here. I can add one more. So look at the first one. This is the Y group. Just imagine a OH in the place of the halogen. You see a carboxylic acid. That is the mother. Her name is 2-methylpropanoic acid. So this acid chloride is the daughter of that mother, 2-methylpropanoic acid. So say the mother's name is Susan. This is her daughter. How will you say Susan's daughter? So we had to modify this a little bit. How we can do it? It is not hard. If your name ends with IC and acid, so you see the IC and acid, strike it off and put YL, 2-methylpropanoyl, and write the name of the halogen as halide, chlorine acid chloride. It is one word. Don't give the gap. It is 2-methylpropanoyl chloride. This is, if you imagine OH here, you see a benzoic acid. The benzoic acid is metachlorobenzoic acid. Same way, strike the IC and acid and put the YL and add the name of the halogen bromide. This compound is metachlorobenzoyl bromide. What if you have a compound of this kind? Say only 5 carbons, and you have CO, say it has iodine. If you imagine OH, you see a carboxylic acid. Its name is cyclopentane carboxylic acid. Now, you cannot actually just strike IC and acid. Here it is, XYLIC. You have to strike it and then replace it with the NYL and write the name of the halogen iodide. This is cyclopentane carbonyl iodide. How to name an amide? Same technique. Imagine OH in the place of the NH2. You see a carboxylic acid. Its name is butanoic acid. And then replace OIC and acid with amide. This is butanamide. Same thing, imagine in the place of Y, OH. you have the same butanoic acid and replace OIC acid with amide, butanamide. You see OIC acid. If you have a common name, you actually replace IC acid. But this has a ethyl group on the nitrogen. So you have to indicate it as a substituent on the nitrogen. It is N-ethyl butanoamide. If you come to this one, if you imagine OH in the place of this, you see a carboxylic acid. It is a pentanoic acid. Same, replace it with a amide, pentanamide. But it has a substituents on the nitrogen. I don't have a space, I'll write it here. It has two substituents. One is an ethyl on the nitrogen, other is a methyl on the nitrogen. And then you make it as one word. If you look at the next one, if you imagine in the place of this OH, you see a carboxylic acid, you name it. It is butanoic acid, replace it with amide, butanamide. And there are two ethyl groups on the nitrogen. So N diethyl. So butanamide. Suppose if you have, for example, in this one, the second example, don't write, just to look. Suppose if it has an ethyl substituent here, you cannot combine this one and this one together and say dimethyl. What is wrong with it? You can do it to N-dimethyl. But the ethyl actually is present on the parent carboxylic acid. So the best way to do it, N-ethyl, 2-ethyl, butanamide. How to name an ester? I have two examples here. This is an R group on the oxygen. Just imagine a hydrogen. You see a carboxylic acid. It is 3-methyl butanoic acid. So what you have to do, you have to convert IC acid into 8. And then name this R group in the front. Methyl 3-methyl butanoate. The name of this in the front. The same thing in this case. If you imagine a hydrogen, you see a carboxylic acid. It is 3-methyl butanoic acid. Replace IC acid with the 8, butanoate. You keep the O. And then the name of this group in the front, ethyl. You need not say it is present on oxygen. The first one is expected to be oxygen. In this case, I used a common name just for a change. You can use the IUPAC name. This has 2 carbons, so it is ethanoic acid, but I used actually a common name. So you see an acetic acid, and then IC and acid, you take 8 acetate and put this ethyl group here. So this is ethyl acetate. What about in carboxylic acid's name? There also you are going to replace IC and acid. This is oh, I'm sorry. This is a carboxylic acid. So this is OCH3. That is an ester. So if you imagine a hydrogen in the place of CH3, you see a carboxylic acid. It is a cyclohexane carboxylic acid. As usual, ICN acid. Put the 8 and write the name of the methyl group in the front. Methyl cyclohexane carboxylate. How to name an acid anhydride? Anhydride contains 2 acyl groups. If they are the same, it is a symmetrical anhydride. Look at this one. Both the acyl group contains 3 carbons. They are the same. So it is a symmetrical anhydride. If it is a symmetrical anhydride, go to one of the acyl group, any one, left or right, and imagine a hydrogen. You see a carboxylic acid. It contains 3 carbons. Its name is propanoic acid. Just to strike off the acid and write anhydride. This is propanoic anhydride. If the 2 groups on it are different, you see this has 2 carbons, this has 4 carbons. This is unsymmetrical. The 2 acyl groups are different. So what to do? This has 2 mothers. The others have 1 mother. This one has 2 mothers, a biological mother and surrogate mother. They are holding the baby's hand and walking on the sides, both of them. So first imagine a hydrogen in the place of this. You will see a carboxylic acid. Its name is butanoic acid. And then next, you go ahead and take this off and imagine a hydrogen in the place of this acyl group. You see a carboxylic acid, that is ethanoic acid. And put them in alphabetical order. In this case, fortunately, the left one is butanoic, the right one is ethanoic. So after writing it, strike off the acid in the first one. In the second one, change it into anhydride. So this compound is butanoic ethanoic anhydride.